and welcome to DevSecOps for cloud-native apps. My name is Sven and I will explain you what security has to do with cloud-native apps. If you're interested in this, stay tuned. DevSecOps for cloud-native apps. What's cloud-native? What has security to do with this? Before I'm starting to talk about the security aspects, I want to have just a better view about the cloud-native topic. So it's a very broad topic, and there are a lot of definitions, but in the end you will find some common approaches. So you have, for example, these different layers cloud-native apps are organized. So you have, for example, the first one, the service-oriented architecture. Then you have the requirement of API-oriented communication, container-based infrastructure, and DevSecOps for the management. So what I want to reach with cloud native, or with this way of composing my applications, I want to have shorter release cycles because I want to have this agile approach. I want to have very tiny parts of my app that are developed independently, and so on and so on. So it means if I have different tiny tools that I'm composing to a bigger system, then mostly it means the lifetime of a shorter or smaller component could be short, because if it is just a tiny part, then instead of maintaining it, I would just rewrite it. So it means the life cycle of every component could be very short. The system can run very long, and it's mostly based on the composition of different tiny fragments that are building the whole production line, the whole value of the system, what you have. One thing is that if you're just talking about API-based communication or service-oriented architecture, that every part of this big system can be written in different languages with different toolings and so on. So we are talking immediately about a polyglot world. A polyglot world will lead to polyglot security holes, more or less. But I want to focus now on some other aspects. So first of all, if I'm looking at one single point here in this cloud native world, so one dedicated part of the application, one microservice that will be created, then I have something like an application itself. The application is maybe written in Java, so I have this dependency management system called Maven, for example, and with this I'm managing my dependencies if I need some additional libraries or whatever inside this one. The next thing is that I'm wrapping this one, or it must run on Linux. So I have the next repository type here, the Debian repositories, for example, and to manage the dependencies here in this operating system layer. And everything will be wrapped inside Docker. So here I'm talking about Docker repositories that are corresponding or that are part here to define dependencies and all this stuff. And the last layer would be some Kubernetes universe where everything will be orchestrated and is running, so and it's managed. So for this tiny tool that is part of the big system, we are using DevSecOps as the management or the way to management the implementation, the runtime, and the maintenance and all this stuff. So what we have here, we have on the one side use case driven requirements. So for example, if the use case fits to the business and all this stuff, here it's not so easy to get help by toolings. But if you're talking about the low hanging fruits dependencies, and license checking and all this stuff, then we have excellent tooling available here from JFrog. So this is, so over all layers we have some part of dependencies, and in every layer we have one part that is more technical driven, just the technology itself. One part it's just driven by the use case itself, so if this use case is adequate to my business case I want to implement. And on the other side I have this part of dependencies, and dependencies means I'm trusting other implementations or people. So what does it mean? If I have now all these layers, every layer with different technologies, every layer with different risks, and means that the whole amount of vulnerabilities for each layer, in the end you have a composition of security holes or vulnerabilities that will give you the full amount of attack vectors, and the that's more or less what you have to think about. So every layer will give you more vulnerabilities. On the other side, it means if you're killing these vulnerabilities in the earliest layer, then they can't be part of the next layer, they can't be part of the composition of security issues. And the first layer we're talking about is the application itself. So if you start deleting or killing vulnerabilities during this coding phase and just thinking about dependencies, then you have the most impact for all the other layers. So there is one term that's called shift left, where this shift left is coming from. It's more or less exactly what I mentioned just a few seconds ago. If you're rotating this picture of these layers from application up to the Kubernetes layer by 90 degrees, then the application would be the left side and the Kubernetes layer would be the right side. And this is exactly what is meant by shift left. If you're starting with security as early as possible, so on the left side during the application and even before this one, then you have the most impact of the first actions. What I want to cut out here is explicit the concept phase. Security is part of the concept phase for sure. It's the same like a good algorithm. So if you have inside your concept phase a good algorithm developed, then the technical implementation of this algorithm could be faster or slower, but a better algorithm will always be the winner compared to a not so good algorithm. So it's the most critical thing is for sure inside the concept phase. So even with security should be part of the concept phase, but the tooling itself will help you everything that is coming after the concept phase. So this is why I'm excluding the concept phase here, and I'm just talking about the application layer and all followings. So this is one thing. Back to the application or to the technical layers where the tooling can help you most or easily, is that if you have, for example, for every layer some corresponding repositories, means for the application maybe Maven, for Debian, the Debian repositories for the Linux layer and so on, then it would mean that if you have one single repository manager that is able to deal with all the different technologies, would be a perfect place for scanning for known vulnerabilities and compliance issues. And Artifactory is exactly able to handle the most of these package managers. The last time I counted was 26 or so. And even if there's your package manager not available, you have generic repositories. So with this you have one logical single point where you can start searching for vulnerabilities inside the binaries, and this is done by X-Ray. X-Ray itself is able to scan the content of Artifactory, and the good thing is you can use it via the web UI or just via REST. And if you're doing this one via REST, then a machine can consume the result or can configure or can deal with exactly this stuff as well. How to map now your compliance or security rules that written down in some documents, for example. The main thing here is that you have three things that you can use, or two things to define what should happen. You have rules and policies. Policies are just a composite of rules, and these rules are defining if I find something with a CVSS or with a score, with a security ranking of high or medium or whatever, then do something, so this action. So what you could do is you can map easily these documents you have already to rules and policies, and later you're mapping this one or combining this one via watches with your repositories you want to scan. This is, we need a little bit more to understand or to do it, but I have two how-tos about this that will show you explicit how to deal this one. These are JFrog how-tos. One is called rules and policies and the other one is called watches. Check out my YouTube channel, you will find them easily there. So what is now a part, or how to get these low-hanging fruits? Getting these low-hanging fruits means that you should start as early as possible, and the earliest part you can start scanning for vulnerabilities is just after you added the dependency. You're adding a lot of dependencies because you don't want to reinvent the wheel, but at the same time you have to trust exactly these people that are doing safe stuff and they are not mixing up license, for example. So assume you have a proof of concept, just a tiny side project, and you want to start with a first code of line of code. Then you add a dependency to your POM, and immediately what you should see is that you have or have not a compliance or security issue. And this is done by the IDE plugin, for example, from JFrog. So we can hook in the IDE, and this IDE plugin is scanning, for example, the Maven part or the NPM part or whatever, and will give you immediately the feedback from X-Ray. These binaries you are just requesting have some vulnerabilities, for example. So I will show you here a screenshot of this one, but I have a dedicated how-to about this one, how to use this IDE plugin and how to harden against, for example, a web application stack called Vardin. So then you will see how this is done in practical life. It's just adding a dependency, checking it, and removing transitive dependencies that has vulnerabilities or changing versioning. So if you have done this one, the next step would be that you want to wrap this, for example, in Docker. And what you're doing here is just you start writing your first Docker file, and the first statement is a from statement. Again, you have to deal with dependencies, and it would be great if you would see immediately what's going on in all your Docker layers you're using. So one thing here is that if we are adding our application to Docker, we immediately have an impact graph that's not only based on one technology. So for this, it would be great, or it is great, to see the full impact graph. So here in this web UI, you will have the possibility to see this jar is maybe part of this Docker image and has this vulnerability. So you'll see the full impact graph, and this is done over all technologies we are supporting, and then you can see what's going on here as well. So next layer would be, after you have your Docker file done and your Debian repository is scanned and your Docker file is scanned for vulnerabilities already, the next step would be let it run in Kubernetes. And again, what's part of it? It's a repository where you have your Helm charts, for example. But if you're reading a little bit about Kubernetes, it's interesting to see that the most security issues you have are something like usage of plain text passwords, using unsecure libraries, bugs, operating system bugs, and so on. So what it means is, okay, you have some stuff like don't use plain passwords. This is something you should do in your process to get rid of this one. But on the other side, we are mostly talking about dependencies, insecure dependencies, bugs in operating systems, and so on. And it means here again, you're just dealing with dependencies, you're just dealing with repositories. So if you're going to this dependency management itself, this is really a low-hanging fruit. There's just one thing that you should have in mind. If you're using existing Docker containers, how to harden them, you can do it manually, but have in mind that we have a REST interface, so you can manage the whole JFrog platform. And with this, you can build dynamic workflows to harden Docker images semi-automatic, for example. There's one thing left. If you're dealing with Kubernetes and the Kubernetes cluster want to ramp up some Docker images, you must make sure that everything that is requested by Kubernetes will go to your Docker repository, will go over your Artifactory instance. For this, we have a Kubernetes Dynamic Admission webhook, and this is a GitHub project. Let me read, jfrog/kubnub. It's an open source tool, it's actively maintained. Have a look at this one, because with this you can enforce pulling Docker images over your private repository, and with this it is scanned. With this you can block downloads. With this you have the overview what is inside your Kubernetes cluster. So again, X-Ray is a way to connect to your third-party components via webhooks as well as REST interface, and with this you can feed auditing systems. With this you can generate reports. With this you can activate quarantine repositories, and so on and so on. The best thing is you try it out. We have a free tier, and I show you here on the slides my JFrog how-to about the free tier activation. Just check my YouTube channel here, and the URL is just jfrog.com/start-free. Then you can ramp up your free tier, and you can start immediately playing around with this and checking what's going on with X-Ray and Artifactory. Yeah, that is so far everything about the Kubernetes stack. Just have in mind, starting from the application, going over the Linux layer, going over the Docker image layer, and hardening your Kubernetes infrastructure. The really low-hanging fruits are checking for known vulnerabilities and dependencies and license issues. That's it. I really would appreciate if you give me a thumbs up for this one, as well as subscribing my YouTube channel. This would be awesome. Otherwise, I really looking forward to have some comments and some suggestions what you are thinking about this, or if you have some other topics I should explain or discuss. And otherwise, I can say thank you for attending, and see you.